Hello Math 1060 class. This is our first final review. There's 3 of them. This is part A. Determine which ordered pairs are solutions of the following system. Here's the system that I'm given. And the first possibility is 2, -4. So remember, you just have to plug in 2 for x and -4 for y. And in order for this point to be a solution of the system, it has to satisfy both equations at the same time. I don't think 2, -4 satisfies the first one, because if you plug in -4 for y and 2 for x, notice you get -4 equals +4. So it can't be 2, -4. And the next point is 4, 14. I don't think that satisfies the first one. If I plug in 14 for y and 4 for x, that says 14 is equal to 12 minus 2. That is false. So it must be 5, 13. Let's just make sure. If I plug that into the first one, I get 13 equals 15 minus 2. That is correct. And I get 13 equals -5 plus 18. So it looks like it's 5, 13. So those are easy. Just plug in the x-coordinate for x and the y-coordinate for y. And just remember, it has to satisfy both equations at the same time. Solve the system of equations by the elimination method. So here is the system. So remember, whenever you use the elimination method, you're adding the 2 equations together and trying to cancel out a variable. So look at the 2 variables. Which one would be easier to cancel out? Probably the y, if I multiply the second one by 4. I won't change the first one at all, but if I multiply the second one by 4, I get -12x plus 4y equals 8. So notice the -4 and the +4 will cancel. I get -10x equals 20, so x is equal to -2. But remember, you always have 2 numbers as part of your answer because you need an ordered pair. So plug in that -2 into either equation. I'm going to plug it into the first one. 2 times -2 minus 4y equals 12. And we'll just solve for the y. So I guess at this stage I want to add 4 to both sides. Divide both sides by -4, that gives me -4. So it looks like -2, -4. And we can always check in the second one. If I plug in -2, -4 into the second one, I get 12. Actually, I get 6. Minus 4 equals 2, and that looks correct. So I know I'm going kind of fast, but you can always pause or rewind the video. Like I always say, these videos are long enough, I think, as they are. Number 3 says solve by the elimination method. So this one is another elimination method, but I have a feeling this one is going to be one of those special ones that might be no solutions or infinitely many solutions. Well, let's just go ahead and eliminate the x. So if I multiply the first one by -2, that would probably do it. But notice that the x's cancel, but so do the y's, and so do the constants on the right-hand side. So whenever you get an equation that has no variables in it, that it is true. The answer is infinitely many solutions. Let's try this one. Number 4 is also solved by the elimination method. Okay. So I guess this one is a little trickier because the coefficients aren't very nice. So I might have to use my little trick. I'm going to multiply the first one by the coefficient of x in the second one. And I'm going to multiply the second one by the coefficient of x in the first one, but I'm going to change the sign of one of them. So I'll just change that 4 to a negative 4. So when I distribute the negative 6 in the first one, I get this. And when I distribute the negative 4 in the second one, I get this. So notice when you add them together, the x's and y's cancel, but this time the right-hand side is not equal to the left-hand side. I believe that's negative 46 on the right. So this is the case where the answer is no solution. So if all the variables disappear and the answer is false instead of true, the answer is no solution. All right, let's move on to number 5. Solve the solution set of the following systems of inequalities. Indicate all corner points and shade the solution set. So here is our system of inequalities. So let me remind you how to do these. What you want to do is make an equation out of the first one. And graph that equation. And I suppose we probably should solve for y here before we try to graph it, because you guys are going to have to enter this into the computer. And you might want to choose points that have integer coordinates, and that's kind of the tricky part. So would x equals 1 work? I don't think so, because I wouldn't get an integer. In fact, you could just plug this into a calculator and go to the table, and that will probably give you the integer coordinate points right away. So that's what I'm going to do. I'm just going to enter this function into my calculator, and then I'm going to go to the table and just look for the points that have integer coordinates between 0 and 10 maybe. And the first one that I see is 2, 6. And the second one that I see is 5, 4. So 2, 6 and 5, 4 are the 2 points that I get from the table. So I should be able to input that into the computer. Let me do that. And notice, by the way, this is a dashed line because of the strict inequality. Well, let's go ahead and do the second one. That is x less than 2. But remember, you make an equation out of it. But that's easy. That's just a vertical line that goes through 2. And it's also a dashed line. But it's just a vertical line. And you can choose any 2 points that you want. I'm going to choose 2, 0 and 2, 1. So I end up with a picture that kind of looks like this a little bit. So remember, the next thing to do is to test each one of these 4 regions. Just one of them is going to give you a true. So pick a test point in each one of those 4 regions, and the only one that's correct is the one that satisfies both inequalities at the same time. So we could start off with 0, 0. I don't think 0, 0 satisfies the first inequality. 4, 0 is in this little region. But I don't think that satisfies the first inequality either. 010 is in this region, and I'm just kind of checking it mentally. And I think 010 does satisfy both inequalities. So it's this little region up here. So what I did was I plugged in 010 into this thing and 010 into this thing, and it satisfied both of them. So that little wedge at the top is the answer. So use that little paint bucket symbol. So we haven't done that in a while. Oh, by the way, they do ask us for the corner point. It looks like it's 2.6, just by inspection. And I'm looking at the computer. It's not as clear on the paper. An average bagel contains 30 milligrams of calcium and 2 milligrams of iron. One ounce of cream cheese contains 25 milligrams of calcium and 0.4 milligrams of iron. If Layla wants to eat a combination of bagels and cream cheese that contains exactly 550 milligrams of calcium and 24 milligrams of iron, how much of each should she eat? So in this one, I suppose we want to let X be the number of bagels, and we'll let Y be the number of ounces of cream cheese. So let's see if we can set up the system. Notice I've already kind of started the two equations there. Let's focus on the calcium first. So for the bagel, we get 30 milligrams of calcium for each bagel. That would be 30x. And for the cheese, we get 25 milligrams per serving. What about the iron? Well, for the bagel, 2, and for the cheese, 0.4. So there's your system. So you can really solve this thing any way you want to solve it. I'm just going to multiply the second one by negative 15. It looks like that would cancel out the x's. So I'm multiplying this thing by negative 15. And I am using the elimination method. So let's add them together. I get a nice integer for y, it's 10. But I just have to plug in 10 for y into, say, this one. That'd give me 30x plus 250. And I believe the right-hand side there was 550. So x is also 10. So it looks like 10 bagels and 10 ounces of cream cheese. An athlete is taking several nutritional supplements. Supplement A contains 3 milligrams of niacin and 60 milligrams of calcium. Supplement B contains 2 milligrams of niacin and 240 milligrams of calcium. This sounds familiar. The athlete wants to take at least 14 milligrams of niacin and 480 milligrams of calcium. Solve the system and draw a graph of the solution set. So first they're going to make you enter the inequalities. So this is very similar to the last problem. We just have inequalities instead of equations. But let's let x be the number of supplements of A, type A, and y is the number of B supplements. Just focus on the niacin. Every one of the XAs is 3 milligrams, and every one of the YBs is 2. And if you focus on the calcium, every A supplement is 60, and it looks like every B supplement is 240. So there's our system. Now the hard part, let's try to graph this thing. So you have to do this on the computer too. So once again, I think I'm going to use my little trick. Make an equation out of this guy, solve for y. And I would just plug that into a calculator and go to the table. And just look for integer points. And it looks to me like 0, 7 is 1. And so is 2, 4. And I guess I'll go ahead and do this one at the same time. So solve for y. 60x plus 240y equals 480. And quickly solve for y. I think that's what we get. And we might be able to just guess the integer coordinates on this one. 0, 2, and 4, 1, I think will satisfy that one. So let me go ahead and input this into the computer. And by the way, notice that both of these boundary lines are going to be solid, because we do have a bigger than or equal to. So choose the solid one. Alright, and I can tell you that I get something that looks like this. We're really only restricted to be in the first quadrant, but I get something that looks like this. And I'm guessing that this is probably the solution set. But let me plug in a point or choose a point. Well, 6, 6 is in this region, and I'm guessing that probably satisfies both of them. It certainly satisfies the first one. Yeah, it satisfies both of them. So that's the solution set. So use the paint bucket symbol. Hopefully they all aren't this lengthy. I don't think they will be. The next few are probably going to be a little faster. Find the product of the following matrices if possible. So again, this goes back pretty far. So remember, whenever you do the product, it's always row times column. So it looks like the first one is just 1 plus 0. And then if I do first row times second column, I get 0 plus 1. And then second row times the two columns. So it would be 0 and 0. And then I think 0 and negative 2. So that's what I get. So again, you always take the row on the left times the column on the right. That's how you get the elements in the product. Find the inverse of the following matrix. Here's the matrix. So I will give you this little formula, but you might remember it. If you start off with an arbitrary matrix A, B, C, D, the inverse is 1 divided by the determinant, which is this minus this. And you just switch around the A and the D, and then you take the other two, the negative of the other two. That's the inverse. So we just have to do that for this particular one. So let's find the determinant first. It'll be 49 minus 30. And that is 19. So it's 1/19. And now what? We want to switch these two around. Well, that won't change anything. But we want to change these to their negatives. So -6 and -5. And you just have to basically divide everything by 19. So that's it. And I will give you that little formula. Actually, I won't be there, so I'm not sure what I'm going to do about that. You might have to remember that. Well, these are homework assignments. These aren't quizzes, so a little less pressure on these final exam reviews, I think. Let's do number 10. It says 14.1 is what percent of 60? Okay. So the way I like to do these is literally translate it. 14.1 is what percent of 60? So remember, is always translates to an equal sign. Of changes to multiplication. So you just have to divide both sides by 60. That's one way to do it. You could also set up one of those proportions if you like. But whenever you do it this way, remember you're given the percentage as a decimal. So you have to change that to a percentage by moving the decimal to the right two places. You don't have to change it if you use the proportion method. 32.37 is 20.75% of what? Okay, so let me literally translate this into an equation. 32.37 is 20.75% of what? Remember, what always translates into an X. $156. And you don't have to move the decimal around on that one because that's just a number. That's not a percentage. You don't have to worry about it. You know, the other way to do that problem is just set up the proportion. Remember, whatever follows the word of goes on the bottom. You could also solve that proportion for X and you'll get the same answer. According to a Census Bureau, from 2000 to 2016, the population of a certain region grew from 282 million to 324 million. What was the percent increase? So remember, the general formula for the percent change is the final value minus the original value divided by the original value. And the original value is not always smaller. In this case, I guess it is. But it ended up being 324. It started out being 282. But just remember, this will give us the percent increase in the form of a decimal. But it says round to one place, so I think they're looking for 14.9%. But again, these are just regular homework problems. These aren't quizzes. We've only had 5 quizzes in the course. The 4 test reviews and then that SLO thing. You are given an annual interest rate in the compounding period for 2 investments. Decide which one is the better investment. So, looks like we're doing finance here. So, is it better to do 8.7% quarterly or 11% yearly? So, remember, both calculators have that effective rate function. I know for the TI-84, I go to Apps, Finance, and instead of choosing Solver, I scroll up to effective rate. And you'll see something that looks like this. So probably the best way to do it was with the calculator. And on the Inspire, I go to Calculate Mode, Menu, Finance, Interest Conversion, and then effective interest rate. That's how you do it on the Inspire. But we did that already in class. But remember on these, go ahead and enter the percentage first and then the number of periods. So that's 8.7% quarterly. Let's see what the effective rate is. $8.98. Actually, it's 8.988%. Well, let's do the other one now. It's 11% yearly. That's really just 11%. So clearly this one is the better one. Use the formula for computing future value using compound interest to determine the value of an account at the end of 10 years. If a principal amount of $15,000 is deposited in an account at an annual rate of 3% and it is done monthly. Okay. So we're putting it in there for 10 years. We're investing $15,000. This looks like just a regular investment. We don't have any payments in this one. The annual rate is 3% and it's done quarterly. Actually, monthly. So this is a solver problem, a TVM solver. So go to Apps, Finance, and Solver on the Inspire. I'm sorry, on the TI-84. Now, let me just show you what I'm going to input. N, remember, is the total number of periods, 10 years monthly. The interest rate is 3%. The present value is negative $15,000 because we're investing the money. We're taking it out of our wallet and putting it in the bank. No payments in this problem. The future value is what we're looking for. We'll zero it out for now. And what about the last two numbers? Well, monthly means those are 12s. So go back up to future value and alpha enter it, or just press enter if you've got the Inspire. And I get this. And that looks about right. It should be a little more than 15,000. Last problem of this particular video. This is just part A. Use the average daily balance method. This one is kind of a whopper. To compute the finance charge on the credit card account for the previous month, the starting balance and transactions on the account for the month of April are shown to the right. And we have an annual rate of 18%. All right. And let me just give you a summary of the table they gave me so you know what I'm doing. And you're going to have to do something similar. But we've done all this stuff before. And I'm not going to say what the charge is for, but we made a charge of $97 on the 10th. Then we made a payment of $520 on the 12th. On the 17th, we charged $184. And then we charged $12 on the 26th. And the previous month's balance was $540. So let's find the average daily balance first. So it looks like it was the same from the 1st to the 9th, and that's just 540. It didn't change until we got to the 10th. And on the 12th, we did something else. So from the 10th to the 11th, we charged $97. So I'm going to add 97 to 540. And then from the 12th to the 16th, well, starting on the 12th, we made a payment of 520. So I'm going to subtract 520 from that. And then from the 17th to the 25th, we charged 184. So add 184. And then from the 26th to the end of the month, and I believe there are 31 days, actually 30 days in April. They tell us that. We charged $12. So remember, the trick is to count up the number of days. That's 9 days. That's actually 2 days. 5 days. That's 8 days. Remember, you say 25 minus 17 plus 1. 9 days then. Sorry. 25 minus 17 is 8, plus 1 would be 9. All right. And what about this last one? It looks like 5. And let's just make sure these all add up to 30. I think they probably do. 11, 16, 25, yeah. It adds up to 30. So now I'm going to add up all these numbers. And I get this. But remember, you have to divide by the number of days in the month to get the average daily balance. So that's my average daily balance. So finally, compute the finance charge. So use the simple interest formula, I equals PRT. So the P is the average daily balance. And the R is the annual rate, which is 18%. Now what about the time? Well, on these, remember, you take the number of days in the month and divide by 365. On the previous day, unpaid balance method, it's a little bit different. You just say 1/12. But on these, it's the number of days in the month divided by 365. So I get 542. And that should do it for video A.